Hi all, a very good afternoon. So today I will be showing you the another project regarding the machine learning. So dataset on which we are working today will be the house price prediction. So let me show you from where you can download this dataset, and that is the house price prediction dataset, and it is available over the Kaggle website. Okay, so this is the dataset, and you can read the context about this. Okay, so it's a regression challenge or regression. So regression type of data set, and these are some of the attributes that is the posted by under construction, RERA approved or not. So available for resale, address, longitude, latitude. So these are some of this attributes of the data set. And after downloading the dataset, let me show you the training part, train test file. Okay, so yes, so this is the dataset. Let me increase the cell size. As of 15. Okay, so this is the dataset, and it is the posted by whether it's a dealer, owner, right? It is under construction or not, BHKs. Okay, so square feet area, ready to move in or not, available for resale or not, right? And address, longitude, latitude, target price in lakhs. Okay, so without wasting any time, let's directly open a Jupyter notebook. Wait a minute. Yeah, I'm opening my Jupyter notebook. So you may also you choose any of the tool you may need, like the PyCharms. We have the Google Colab, and but I found the Jupyter notebook as a more user friendly. So I usually prepare all my projects over it. Okay, let's directly open a new notebook, and let's just import some of the libraries. So let me just first of all rename it house. Okay. So let's just import some libraries like the pandas, NumPy, some of the visualization libraries like the Matplotlib and the Seaborn, and some metrics so that we could test on our data, and for splitting the data into the training and the testing. Okay, so import pandas as pd, import numpy as np, import matplotlib dot upload as pd, import cmon as sns, and along with that, let's also import the metrics from sklearn, import metrics. Okay, and also import the train test split from sklearn dot model. Yeah, importing the train test split. So let's just run all these libraries. Yeah, now all these libraries are installed in our machine. So now let's import the dataset. To import the data, simply write df is equal to pd dot read csv, and the file name is train dot csv. So this is the data, right? And let's give me some of the information. If you write df dot columns, you will get the name of all the columns. Df dot shape will tell you how many rows and columns we have in our data, right? And if you write df dot describe, you will get some of the statistical information about the data, that what is the count, what is the mean, standard deviation, minimum value, percentile value, that is the 25, 50, 75 percentile, and the maximum value. So these are some of the properties of our data. You may also get the df dot info to get some little info about the data, about the data type, memory usage, right? And to check whether we have the null values or not, you may simply write the df dot is null, sorry, is null dot sum. So in our data we have zero, null or none values, so we don't need to fill any of the data. And now just directly mm, now just directly do some of the activities on our data, right? So now let's do one thing. Let me first of all, let me provide a y variable y to this column, that is the target price in lakhs. And let's just click copy it, and so this is the y. Yeah, okay, if I show you the y, so this is it. Yeah, so we have the target price in lakhs, and drops some of the columns that are not needed. Say for example, machine learning generally not work over the object type of data type. Okay, so for the timing I am just dropping it, or you may just apply the label and coding techniques, so that you could convert your object data type into the integer or floating type of into the integer type of data set. uh, Let me do one thing. Let me have some of this label encoding, right? Yeah. So yeah, yeah. So this is the library, that is the label encoding. Okay. So okay, so it just converts your values between in the 0 and 1 format, right? So this is the way. So for example, you firstly need to import from sklearn, import preprocessing and lead or label encoding. You will fit, and later you will transform your data, right? In this way the things can be applied. Okay, so let's directly go to our notebook. So for the timing, see, I'm not applying the label encoding techniques, but yes, in future for the another data sets, as I will be covering the most of the projects for your job interviews. So yes, in the exam in future I will be applying all that techniques, and will show you how you can do the standard scalar, how you can apply the label encoding, right? Minimum, maximum, how can you do in your data set. So for right now, for I'm just uh, explaining you how can you simply just train and split the data, and how can you and how can you see the metrics of the data, right? So yes, I was just dropping the data that I did not need. So df dot drop, simply write, mm, I don't want put it by. Okay, just simply copy. I'm just copying the data because so that no spelling mistakes could happen from my side, right? Now I want address is also in this object, right? It's done. Address is done. X is equal to 1 and write in is equal to 2. If I show you the df, so yes, this is my data. Uh, let's just do one thing. Let me also, okay, I'm writing x equal to df, and from, okay, so what I will do, if I show you the x, so this is my x dataset, and simply to drop, so now I will be dropping this because this particular column I have defined in the y variable. If I show you, this is my data, right? And let's just drop it from the x, so x dot drop, and I want, no, not the address, I want uh, this. So yes, the I have successfully dropped the column, and yes, this is my data. One thing, I think this BHQ is also in the object format. Let me confirm. Yeah, you may see that the BHQ arc is also in the object format. So for the timing, I am just dropping this. Let me drop this BHP and R. Okay. So now this is the final dataset on which we will be applying some. We will be making the machine learning model, right? One more thing, I forgot to show you the correlation. So if you want to see the correlation, simply write df dot core. So you will got all this correlation, and if you want to represent it in the heat map type of a format, you may simply write sns dot heat map, and simply write df dot correlation. Yes. So this is the our correlation type diagram. So in this, I'm having the negative correlation, right? And if I write note, I'm keeping it as a true. After it, you may see that all these boxes will be filled, and it is more easy to see the data, right? So I guess till now the things are clear to you, right? Let me show you the x and y. So point x and y. Okay, so above this is my x and below it is my y. Okay, so now just do the splitting and splitting of our data. Simply write x train comma x test, y train, y test, into train test split, and writing x comma y, and I am keeping test size, Test size I am keeping right now as zero point 0.2. Like the 20% I'm just keeping as a testing, and the 80% I will be giving the training to the data. Right? And just simply so successfully applied. And if I show you this shape of the data, its shape, in shape and its test dot shape. Okay, so this is the data. So for the training, I am this for the testing purpose. I had the 20% of this comes to be the 5891. Okay, so let me just show you with the this XGB regressive this thing. So simply write. So the I'm using the algorithm that is the XGBoost. So simply write from XGBoost import XGB regressor. Okay. So if yes, if any chance your library is not been the system shows that this particular module is not available, then you need to this install the module, and for that you simply write pip install xgboost. So my this module is already installed with me, and if I could show you, let me show you over this over the website, right? So this is the official website. So you may simply copy it and install the module in your system. Right now there is no need, so I'm just deleting this. Okay, so now let me give the abbreviation that is the model equal to xgb regressor. Now I'm fitting the models. I will write model dot fit xtrain dot and just fitting the model xtrain dot pytrain. Right, the model is fit successfully. Okay, now prediction of this training prediction. Prediction is equal to model dot predict xtrain print. So yes, this is the prediction. So so this is the way by which we can train split the data and things could be performed. Okay, now Now let's just I will apply some of the metrics to our data. So okay, so firstly let me show you the this. Okay, so now score metrics dot r2 to score. I am writing by train comma training prediction, right? And let me take it as a score one, and then I'm taking as a score two. Matrix dot mean absolute error. I'm writing as y train comma training prediction. Okay. So simply write and score one and print score two. So you will get the both of this. So yes, as per the machine, my R2 score is around 99.61 and my mean absolute error comes to be around 21.41. Okay, so there is a little, let me give a little information. I have already prepared the notes, right? Okay, so R2 square often used to measure how well the regression model fits into the data. So how well the data fits or the well the machine learns. So as per are this, so 99% of the data is properly learned by the machine, right? And the mean absolute error ranges from 0 to positivity. We lower the values indicating the better performance, right? So here I am getting the 21.41. But I guess it's a big number. So what in the next we will do, we will apply some we will delete some of the columns that are not needed, right? And we will standardize the data. We will just decrease this uh, all the all the values that are above the three standard deviation or the that are not needed, right? So in this way we can do the activities in the data. So let me show you the print how this graphs actually looks for the our data we have prepared. So plt dot scatter to be the x train comma training prediction. I guess this is plt dot show. Okay, so I guess there is some issues with the code. I will get back in some another video regarding this. So in this way, you can make your own prediction, right? And let's just do one thing. We have done the prediction on the training, and now just do some things over the test data set, which we have 20% that we have kept. So simply write test prediction to model dot predict x test, right? So Same with this. So like score 3 and getting rewrite matrix dot r2 test data prediction. Absolute errors and please write test and test prediction. I'm getting this. Mhm. Okay, there was some. Okay, so just let me just print the score for the test data. So I am getting 94 for this, and it's a good score. And for this mean, I'm getting. So yes, as per our model, we need to work over this matrix mean absolute error, right? So in this way, you may create your own machine learning model. If you have any of the queries, I will be dropping this the link of this website, right? So you it's easy for you to download this dataset, and I hope you learn a lot from this session. And thank you everyone for your precious time, and have a good day. Thank you. See you soon in the next video. I know there was it's a late video, but yes, in the coming days I will be uploading at least two videos in 1 week, right? So thank you so much, guys. I will be coming with more projects and different data sets. So if you want, what you may do, if you want that a particular project needs to be covered or particular data sets, you may just drop the link in my comment section, and it's a request, just like, share and subscribe my channel. So thank you again for your precious time. Have a good day.